For the last section of notes on 8.1, we're going to be looking at what happens when I give you an equation and ask you to prove that it is, in fact, the equation of a parabola instead of some other shape, which we'll look at later. The first thing we need for today's lesson is actually a refresher on how to do something called completing the square. Hopefully this will seem familiar, but I have steps listed out here that you need to get the equation into a specific form. Basically factor out if there's a number in front of the x squared. You shouldn't have a number there. So you need to get x squared by itself, factor anything in front of it out, move any constants to the opposite side of the equation. Then you're going to take the number b, which is the one in the middle, the one that's next to x to the first power. You're going to cut that value in half, or divide it by 2 if you prefer, and then square that number. That number needs to be added to both sides of the equation. And then your last step with completing the square is that you factor the left-hand side, but you don't actually have to try and figure out the factors yourself. It always breaks down to be half of b, the same number we used over here, and then you put the parentheses on the outside to square it. So it's always that number as the factor twice. So let me show you a quick example to kind of remind you of this process if you haven't done it in a while. The first thing I'm going to do is I'm going to move the 5 to the opposite side. And I can't have that number in front of the x squared, so I'm going to factor out a 2 so that I'm left with x squared minus 6x. So I factored out 2 from the left-hand side, and I moved the 5 to the opposite side. Okay, now in step 2, my middle number, the number that's attached to x, is the negative 6 value right here. So I'm going to take half of that number, which is negative 3, and then I'm going to square it, which is plus 9. Now this won't always happen, but in this case I have to be careful. I didn't actually just add 9 to the left-hand side of the equation. Because of the 2 I factored out earlier, that's actually 2 times 9 that I added on the left. So to maintain the balance here, I have to add 2 times 9 to the right-hand side as well to keep it balanced. So now on the left-hand side, I can rewrite that in the factored form as x minus 3. Like I said in the step 3 explanation, it's always half of the middle number b, so half of negative 6 is negative 3, and then it's that binomial squared. On the right-hand side, 9 times 2 is 18. If you take away 5, that's 13. And the next step would be to divide both sides of the equation by 2, so that I'm just left with x minus 3 squared equals 13 over 2. Now usually if you're solving an equation using completing the square, there are a couple other steps that you would perform from here, like taking the square root of both sides, but we don't need those for our purposes of proving that an equation is a parabola. So let's look at an example similar to what you'll have in the assignment. So you can see that there is a little bit of a difference from the example we just looked at for completing the square, because now I have an extra variable. I have a y on this as well. But my first step is not going to change much. I want the x squared and the 2x to stay by itself. I want to move everything else to the opposite side. So not just the constant anymore, but the y to the first power as well. So I moved the y over and I moved the 3 over. Now this one didn't have a number in front of x squared, so I didn't have to worry about factoring anything out, which is nice. So when I go to add the half of b value, b is 2. That's my b term. I'm going to take half of that, which is 1. Square it, still 1. So that's the number that I'm completing the square with. That's the actual completing the square step right there. The left-hand side, that means this factors down to be x plus 1 squared, because half of 2 is 1. And on the right-hand side, I can simplify that a little bit to make this just y minus 2. So now I actually have the form that matches the equation of a parabola. I can see that my vertex, don't forget, we still have the rules that the vertex is h and k. So if I list it out, h is equal to negative 1, k is equal to positive 2, and 4p is equal to 1 in this case, which means p is 1/4. Yes, you can get fractions on these. So my vertex is negative 1, 2, the h and the k value. My focus just to remind you, we have our x squared equation. So I'm looking at the left-hand column. My focus is going to be h and then k plus p. So h and then k plus p. This time I'm adding a fraction. So 2 plus 1/4 is actually going to be 9/4. And the last thing they asked for is the directrix. So let's look back at the formula. You can see that the directrix is k minus p. So I'm going to write y equals 2 minus 1/4 is 7/4. Don't forget to write the y equals, though. That is an important part of it as well. We're defining the equation of a line. That's why we have the y equals in there. Okay, let's do one more example. Now this time it's not an x squared equation, it's a y squared equation, but using completing the square is pretty much the same. It's just that this time I'm going to leave the y squared on the left and the y to the first power. Don't mix and match the letters. Keep the y's or the x's on the same side. So on the other side, I'm going to move the 6x and the negative 13. So this is making it match the form for me to use completing the square. We're trying to get it closer to that parabola equation. Now I take half of b, which is that middle number 2. So half of that's 1. If you square that, you still get 1. I'm going to add that to both sides of the equation so that my equation is still balanced. You can add 1 to both sides and it doesn't mess anything up. The left side will factor to be y plus 1 squared. And on the right-hand side, I can rewrite that as 6x minus 12. Now there is another step I need to perform on this one because usually we don't have a coefficient on x exactly. Usually what we have is x inside of parentheses, and there's something out front being multiplied. So what I'm going to do is I'm going to take out whatever the coefficient is. I'm factoring out the 6. So 6x divided by 6 is x. Negative 12 divided by 6 is negative 2. So we've just factored to get this to better match our form. And now I can see that the h value is positive 2. The k value is negative 1. And since 4p equals 6, that means p is again going to be a fraction here. Divide both sides by 4 and reduce 3/2. So for my answers, the vertex will be the coordinate 2, negative 1. Our focus, this is a y squared equation. So now we're using the equations on the right-hand side. It didn't matter for the vertex, but for the focus, that does change things a little bit. Now it's h plus p, k. So h plus p, 2 plus 3/2, is going to equal 7/2. And then the k value. And for the directrix, looking at that same column, this time it's going to be an x equals equation. I need to take my h value and subtract p. So h is 2. If you subtract 3/2, you get 1/2. So my equation is going to be x equals 1/2. So we've proven that we have a parabola because after we completed the square and factored a little bit, we got an equation that matches our general form of a parabola. And once we had it in the parabola form, we were able to label the vertex, focus, and directrix. That's all for the notes today.